Yeah,
Okay.
yeah, okay. So just a little bit of background on myself and my wife, Gerda. We happen to live in Arlington, Washington right now, and we've lived there for, well, quite a while. But my wife and I, we were both born in the Netherlands many years ago. And when my parents decided to immigrate to Canada right after the war, so they finally got booked in 1948. My parents had 5 children in Holland, and I'm number 2 in the lineup there. And then, so when they got on the boat in Rotterdam, I decided, well, I probably should get on the boat too. So I did, and then we immigrated to Ontario, and there we ended up in the town of Burlington, which is close to Hamilton and Toronto. And so that's where we grew up. And my parents had 5 more children in Canada, so I'm one of 10, which is a little unusual these days, but in those days it was kind of normal. And my wife's family decided to immigrate in 52. And they moved to different places in Ontario, but they ended up in Burlington, and that's where we met, at a CRC church. And I went to school, Gerda took nursing, and then I got my degrees at McMaster University. And after that, there were no jobs in the nuclear industry, so I was fortunate to get a job at Bell Labs in New Jersey, a research organization, and that was in 1969, and that just happens to be the year that Unix was invented at Bell Labs. So I was very involved in that work, and also TCP/IP networking that was just starting as well. So I was at the forefront of that. Digital switching started in that time frame. So as a result, I spent my whole career in the high-tech industry, working with different companies, different startups, and run a consulting service. But then we have 5 children, and they went through Christian school, and I got involved in teaching them in a Sunday school hour, because I was thought it was important that they know what the word says and to be able to defend what they say. And that's got me into apologetics, integration versus evolution, and the Christian worldview and biblical worldview. So that's what so when I retired, I got into Apologetics Forum. I started the Apologetics Forum in Arlington, and back in 2013. And we've been doing that since. We bring in speakers just like you do. And but our model is a little bit different. When we bring a speaker in from out of town, we take them to about 6 or 7 different churches and 2 Christian schools, because we keep them there from Wednesday night all the way through to Sunday evening. And then we also have local speakers. So we have a number of people that speak on the apologetics topics, and we bring them in as well during the summer and other months. So we pretty well go 11 months of the year. So that's what we do. So why am I speaking on flat Earth? Well, because the church that we were attending, there were some people that believed in flat Earth, and so when they got the pastor came across some people that believed in flat Earth, and he had a visitor come in. He believed in flat Earth and was trying to convince the pastor that the Earth really is flat. So he said, "Why don't you look into that?" Well, that got me going for a while to study the issues, because I couldn't understand why they would believe that the Earth is flat. So with that as a background, I spent a fair bit of time. I've got my website is my name there, HeinzLycklama.com. And I've got, if you look at flat-earth, you'll see all my notes on the research that I've done, the references, etc. And I also refer to 3 other creation scientists, Dr. Rob Carter from ZMI, Jason Lyle, who's an independent speaker and well-known in the creation movement, and Danny Faulkner as well from AIG. So I've studied what they had to say, but there's also new issues coming up. So the presentation I'm going to give is my understanding of what the issue is. And I'm going to, that's why I call it the flat Earth phenomena. I just don't come out right as saying, flat, it's not flat. But I want to understand why people came to believe that it was flat. So I'm going to cover these 10 topics. The flat Earth concept, what is it? The history of spherical Earth. What is the flat Earth history? What do flat earthers think and say? What does the Bible teach? And then I'm going to spend most of my time on 12 evidence for a spherical Earth, and then 12 challenges to the flat Earth concept. I've maintained contact with a number of people that believe in a flat Earth, and they are believers. And of course, they try to convince me that I'm wrong, but I keep an open dialogue with them. And so I found that it helped me to understand what they believe and why they believe as well. So then 12 challenges of flat Earth, and then what assumptions do they make? 12 flat Earth assumptions. And then you may have heard of the final experiment that was done by people that believed in a flat Earth and a spherical Earth, and then draw some conclusions. So here's the concept. I'm going to run through a lot of these slides very quickly because I've got way too much material to cover. And but these slides are all on my website. So if you want to go and load them and look at like the biblical references, you don't have to write it down here. Go to my website, download the PowerPoint slides, and you'll get all the information there. So here's basically what they believed. At least some people believed in a flat Earth that had a dome over it, and then ocean, of course. But then notice they have the sun and the moon within that dome. And here's another view of the dome, and another view with the moon and the sun, in the dome, in the firmament, and you have the stars also from First Genesis. They believe they're within that firmament, within that domed world. And this is the picture that Answers in Genesis uses to describe what they believe. And so what's unique about their belief, they in the 1800s, there's a person that really thought the Earth was flat and wanted to prove it. And so he came up with the idea of a spotlight sun. In other words, if the sun goes down, where does it go? And they couldn't answer that question. So this one fellow came up and said, well, it's a spotlight and it only covers part of the Earth at a time as it goes around. And here's what it does. You see the sun going around in a 24-hour cycle, and you have the moon doing the same thing, but it has a longer cycle, obviously. So that's the view that they have. They came up with this standard map of the world, believing in a flat Earth. And what's unique about that is that the center of that is the North Pole, and then all the other lands are around it. And at the edge of the Earth is the Antarctic. It's an ice wall. They believe it's an ice wall. It's not really a continent. So that's what they believe. So a summary of the flat Earth concept. The Earth is a round stationary disk, 25,000 miles in diameter. And now we know the diameter of the Earth is 8,000 something. But if you multiply by pi, you get 25,000. So if we measure the sphere 25,000, it's got to stretch it out. So the diameter is now 25,000 miles. But the sun and moon are the same size, roughly, in their view, and only 32 miles in diameter. Obviously, they have done they can't support these kinds of things by any physics that we're familiar with. The sun and moon, they orbit around the northern axis, and the stars that they could see, and about 1,000 stars without the telescope, and then they had 5 visible planets as well. You can actually, in the sky, if you look closely, you can see these planets of Jupiter, Venus, Mars, Mercury, and Saturn. And so that's in the order of the diminishing brightness. And then you have the Antarctic wall, they call it an ice wall. So backing up to the spherical Earth history, when did people come to know, without accessing referencing the Bible, to think that the earth really was a sphere? When I researched this, I was surprised at what the Greek astronomers and mathematicians came up with. They actually believed that the earth was a sphere very early on. And so they thought there's, here's Pythagoras, you have this, this here, 8 spherical circles. And, but so he mentioned that he thought it was a sphere. And then others, I'm not going to read all of these because they're just way too much to cover tonight. So, and then even one of the astronomers, Aristarchus, said that he thought it was a heliocentric. In those days, people thought geocentric, the Earth is the center. So he came up with the idea that it's heliocentric, but that never went anywhere, but it is mentioned. Okay, so then how do we, some of these philosophers, they knew how to do measurements. So they could make a guesstimate of how far it is from the Earth to the moon by doing a parallax measurement. So because you can you can go along the surface of the Earth, you can measure that distance, you can measure this angle from the zenith there, and you can measure this angle, and doing the trigonometry, you can figure out roughly how far it is from the Earth to the moon. And they could also do that with stars. If you assume that the sun is at the center of the solar system, you have the Earth, and 6 months apart, the Earth is on the other side of the sun. So you can measure those angles and triangulate and pretty well guess how far it is. They couldn't be exact, but they were close, very close. Then along came Eratosthenes from Cyrene, and he lived 2 centuries before the time of Christ. He was the first person to actually estimate the circumference of the Earth. And how did he do that? I'll show that in the next slide. And then another one here, is an astronomer. He's the founder of trigonometry, which you need to understand how to do, of course, to do these measurements. So here's what he did. In Egypt there's a city called Syene, and there's a well. When the sun is directly overhead and the well is deep down, I mean, it actually is perpendicular to the Earth. But then when you get to Alexandria, which is this distance away, then if you put up a pole perpendicular to the Earth, you can see that angle here turns out to be about 7 degrees. So if you multiply it, or divide 7 into 360, you come up with roughly 7 degrees. And so with that, you can guesstimate the size of the Earth, the diameter of the Earth. And he came very, very close. But of course, I tell the flat earthers that, and they don't believe that really happened. Okay, so spherical Earth, more in history. We move along now to Ptolemy, and he's the one that really is named as the originator of the geocentric model, with the Earth at the middle, in the center, and then some object that they could see, including the sun was just another object, and the planets around that. Okay, that was the model. Now you can make that model work, but it's very, very difficult. The math becomes very difficult. So then then there are these classical planets. These are named like the sun and the moon. You can see the sun, you can see the moon, you can see these 5 classical planets: Jupiter, Venus, Mars, Mercury, and Saturn. So from the brightest to the dimmest. So these planets are all visible to the naked eye without the use of a telescope. And then along later comes Copernicus, who gets us into the heliocentric model. So for 1,400 years, people really believed that the Earth was the center of the solar system. And it took 14 years to change that paradigm. So Nicholas Copernicus had a lot to do with that, and then along comes Galileo, a very controversial fellow, but he knew what he was talking about. So he championed the Copernican heliocentric model, and then came Kepler, who's a very famous astronomer, and his goal in life was to discover how God created, what he created, and how it worked. And so he was very proficient at doing that. So he developed the 3 laws of planetary motion and discovered that all planets actually moved in ellipses. Remember, the Greeks thought the perfect world, all the planets go in a circle. They're a circular orbit, but no, it turns out they're slightly elliptical. And so he's the one that discovered that. So then we go to flat Earth history. Where did that come from? Well, flat earthers was believed by some ancient cultures, but it was never taught by early church fathers at all. And then along in the 1800s, 1838, to be precise, Samuel Rowbotham, he was a UK philosopher more than a scientist, and he was convinced that we lived on a flat Earth in 1838. And why? The next slide I'll show you. And then, but he's also famous for having published the pamphlet on zetetic astronomy. I'm sure most people have never heard of what that is, and I hadn't heard of that either. But you'll see my summary slide will show why that's so important. And he wrote a book by that name, the Zetetic Astronomy. Earth is not a globe. And so he was out to prove that it was flat. And then later on in this century, people like Eric Dubé came along. Now he's not a physicist, he's not a scientist, and but he came. He really, he read the books, okay, and or he read what Rowbotham had to say, and he took off from there, and he documented 200 so-called proof that the Earth was flat. Now, if you look at them, they're not scientific, they're not real. But nevertheless, the people that believe in flat Earth believe that they are real. So the interest in flat Earth increased. You go to the YouTube and do a search for flat Earth videos. There's all kinds of them by these people. And so this was taught not just by believers, but non-believers as well. Dubé is not a believer. So that brings us to what Samuel Rowbotham did in 1838 in the UK. He found a canal like this, and he looked at 6 miles of that canal. And if you look, it seems to be flat. And so he decided to do some measurements. So what he did, he was out to prove that the Earth is not curved, it's really flat. So he used a telescope, but he held it about 8 inches above the water level here. And he said he could see a flag at the other end, or a bridge at the other end, six miles away. And so said, okay, this proves that the Earth really is flat. Okay, then comes along Alfred Wallace, who happened to be a land surveyor. And so when you do land surveying large areas, you have to be familiar with the curvature of the Earth. And I have a son who is a land surveyor. He showed me the documents that they use for that purpose. So he came along with a different experiment on that same 6 miles. And what he took into consideration was atmospheric refraction. In other words, light refracts as it goes from one density of the atmosphere to the water or another density, then it bends, light bends through that to the water. And so he knew about that, and he knew about surveying. So what happens is when if you look at the Earth here, you can see a body out here. You can see the sun, But with the layers of the atmosphere, there's some refraction depending on what the temperature differences are and factors like that. And so that it really is down further than you think it is. And you can see some of that when you have a sunset, say, I'll come to sit and it already go down, but refraction has something to do with that. So he looked at this 6 miles and he used a pole, I think it was 12, 13 feet long, and put it at one end of the 6 miles, and in another one with a telescope, also 12, 13 feet tall. And he put a pole in the middle of the canal, also 13 feet tall. So if there's no curvature in the earth, then you'd expect to be able to see the top of those poles all on the same level. Well, he noticed that he could see in the middle of that because of the curvature. So that proves that there is a curvature to the earth. And so we have two different views. But then another scientist came along, Henry Oldham, and repeated that experiment and also got the same results as Alfred Russell there. So the major proponents of flat Earth today, you will hear some, as I mentioned, Eric Dubay. He has produced many flat Earth videos, starting in about 2010. He's not a believer. He's actually a New Age neo-Nazi, and he's not a scientist. Mark Sargent, who actually lives in Washington, and Flat Earth Dave is out there, selling the whole flat Earth concept. And Rob Skiba is another one. And then along comes a Pastor Dean Otto in Alabama. He's a pastor of a church, and he believes in the flat Earth. And so he preaches flat Earth. Every sermon touches on the flat Earth concept. And their flat earthers, the one that I talked to, they listen to him, but it's not science. So what do they say? Well, they say, Newton discovered gravity, the law of gravity. They say gravity doesn't make sense. That's not how things are held up. It's the buoyancy, the density. If you have a dense ball in this light air, yes, it's going to fall. But that's not gravity. It's not gravity doing that. So that's one assumption that they make that makes the results wrong. Okay, and then it always comes up. You got the Earth spinning, the Earth rotating, and if you look at the distance, it is 25,000 miles in one day. So that means the Earth is spinning at 1,000 miles per hour, and you think water sticks to it? And gravity is not a force that we know about. So the water, if it was really rotating, the water would just go away. So that's their belief. So they don't believe in the law of gravity. And the other argument they like to use, you look at rivers, where do they run? They run from a high mountain, a hill, down to the waters, and then evaporate and water goes back up again. But they say, but there are some places on Earth where the river, it seems to have to run up to get to a certain place. And of course, that doesn't work. So anyway, let's see. And they believe that, we and all school children have been indoctrinated with the spherical Earth. And that's why it's so hard to convince them that it's flat. So Eric Dubay wrote a book, said he's not a Christian. He came across the century-old writings by Robotham, and that rekindled the flat Earth movement, and that was the mid-1800s. And it didn't grow a whole lot in the late 1800s or the early 1900s, but with the invention of the internet, everything's available. All this information is available. People watch YouTube videos which said the Earth is flat. Okay, so then we look, what does the Bible say? There are a number of people who have looked at the verses that seem to indicate, maybe you could say that could indicate a flat Earth. But if we looked at them closely, and my colleague Rob Carter, who's with CMI, and Dr. Sarfetti with CMI, they both looked at these 200 so-called flat Earth verses, and say they don't really talk about flat Earth. And here's what they say. Most of the verses have nothing to do with the flat Earth argument. In classical terms, these are called non sequiturs. They take a statement which says something is flat, but it's not talking about the Earth. It's talking about something else. So they're not even associated with that. Class 2 verses are ambiguous in relation to the shape of the Earth, and it could be considered equivocal language. The third term is verses that involve a misreading of non-modern English terminology in some older versions. Often they pick verses that supposedly prove their case. And so here are some examples. They use the phrase 4 corners of the earth. Now, there's only a few places in the Bible that refers to 4 corners of the earth. And like here in Isaiah, Revelation, and 4 corners of the earth. Now, they believe that the earth is flat, but it's a disc. So where's the corners? I mean, that's not even, doesn't make sense to use those verses to prove a flat earth, because they think it's circular disc. The ends of the earth is another phrase. They said, look at the ends of the earth means that if you go far enough on the earth, you're going to come to an end. There's an edge. So that's how they interpret that. But if you read the verses that they're referred to, it's not referring to geography. It talks about people all over the earth. And those references in the Bible. We spread the gospel through to all ends, to the ends of the earth. I mean, that's a phrase. So that's not referring to the shape of the earth. And then it talks about pillars. It shakes the earth out of its place, and its pillars tremble. When the earth totters and all its inhabitants, it is I who keep steady its pillars, and so on. There's a few references to that, but many of these verses are found in poetic books. I mean, we regard Psalms as poetic books. It's not talking about scientific geography. Then another one, and this is a kind of core. They take the Hebrew word rakia, interpret that as a dome over the earth. And you remember those pictures I showed you at the beginning of the dome? They said, well, yes, that's a dome. But when it talks about a firmament, that's a dome. Nothing can be above that dome. And so, but that word is based on the verb raka, which means to spread out. And so modern translations interpret that as the expanse, not the firmament, but the expanse. And so Genesis 1:14 to 19 places the sun, moon, and stars in the rakia. That's how they would interpret it, but it talks about the expanse of the universe. And let's see. Yeah, and some translations have referred to it as the sky or the Earth's atmosphere. Okay, then what about are there verses in the Bible that indicate that the Earth is a sphere? And that brings to mind verses like Isaiah 40, verse 22. It is he who sits above the circle of the earth, and its inhabitants are the grasshopper, who stretches out the heavens like a curtain and spreads them out like a tent to dwell in. And so here's a circle. And then here, Job 26:7, he stretches out the north over the void and hangs the earth on nothing. This is Job writing 2,000 years ago. He's hanging the earth on nothing. We are out in space as a separate entity, and that's the sphere of the earth. And Proverbs 8:27, when he established the heavens, I was there when he drew a circle in the face of the deep. So there are about 100 verses that people have identified that could be referring to a spherical earth. But actually, when it comes down to it, there are no clear verses in the Bible which say one way or the other. but the Bible is consistent with the spherical Earth. Okay, so now I want to give you 12 evidences for a spherical Earth that people that believe in a spherical Earth use. And these are the 12 I'm going to show you, and I'm going to run through them, each one of them just briefly. And I think you can see the concept they go. First of all, you've seen boats disappearing over the horizon, or when they come into the shore, into port, they come above the hull comes up, and when it disappears, it goes down. And that's what we would expect if the Earth is spherical. Oops. So, and that's hard to argue against, but nevertheless, you can have, and here's a good picture of what we mean by that. And there's a little bit of trigonometry involved in this, and I can explain this a bit. You remember the Pythagorean theorem? A squared, oh boy, a squared is equal to b squared plus c squared when you have a rectangle or a triangle. So you got the radius of the Earth, 4,000 miles, and then you go a distance out here, and then the distance to the object out there is then r plus h. That's the height. Well, if you do the trig, r squared plus d squared, you got r plus h, but r is so much bigger than h. So for small h, you can bring that down to h. This height is equal to d squared, this distance in miles, divided by 2r, twice the radius, the diameter. So for 1 mile out here, you'd expect the horizon to go down by 8 inches, and so on. You go 2 miles, 6 miles, go down 24 feet. So this here, is a measure of how much off you are. So that's what these numbers are here. And but in reality, you could have an object out here that actually it appears to be out here, but it's actually down here. And that's where refraction comes in. And the refraction depends on temperature and density. And so it can't never be exact. So here, for example, if you look from Olcott, New York to the Toronto across the Lake Ontario, which is only 39 miles, but yet you can see that the actual length of this, you can't see the whole length. So the number of feet underneath the horizon, it is taller than you think it is. And the further back you are, the shorter it's going to be above the water. So this is, in reality, that shows a spherical Earth. Now there's a website that I've come across. It's called flatearth.ws. And that gives you all kinds of debunking arguments for a flat Earth. And so they explain the refraction here. The strength of the atmospheric refraction is not constant, depends on the weather condition and varies on the different seasons, different days, and different times of the days. So if you have low refraction, this building is not visible, because if you're over here, you can't see it. But if you have a medium refraction, there's bending of the light, then you can see part of the building. And that's what we're seeing in the horizon in Toronto there. And if you have a high refraction, you could almost see the whole building. But that all depends on the environment. So as explained here. So that explains the impact of refraction on measurements. So the second argument we use for the fact that the Earth is a sphere, when a lunar eclipse happens, you can see the shadow of the Earth, of the moon on the Earth. And And so the ancients used this to also to explain, believe in a spherical Earth. So this is a very strong argument for a spherical Earth, though both of those are. This was recognized even back 4th century BC by Aristotle, and is seen with both a moon and the sun in the sky and the Earth in between. So the time-lapse photos, these are time-lapse photos that you see down here. Next, here's a total solar eclipse. If you have it, I don't know if you've ever seen those total eclipse, and I haven't either, but I've seen pictures of it. The sun is like in the spherical model, it's 93 million miles away, and the moon is in between the sun and the Earth. And so for certain parts of the Earth, the sun is blocked totally. And by measurements or by some trigonometry, you can figure out exactly how wide that is and how long it is. Okay. And here's a picture of, if you look out in the sky, the moon, the sun, the planets, they appear to be spherical. So they appear to be spherical, so they probably are. Then there's the notion of the classical planets, the planets that you can see with the naked eye, before the telescope. Those 5 that I mentioned before refer to the classical planets. So you can see them in the sky, even in the heliocentric model here. So they're quite visible. After the telescope, of course, we could see other planets and other constellations of the stars, and we could see a lot more. The 5th argument is in the days before the 18th century, people didn't drive by cars or by car and train or whatever, and they just moved within their environment, so you couldn't tell that the sun was rising at a different time the further you go. And so when people discovered that, then they said, okay, we have to have time zones. And that's why time zones are about, because you like to think about the sun rising in the morning at a known range of hours and then setting at another range of hours. So this wasn't introduced until the 18th century. And of course, that was just before Rowbotham came out with his theory. But back in the 13th century, here was a person who astronomer John Sacrobosco, he wrote this, that the Earth too is round is shown thus. The signs and stars do not rise and set the same for all men everywhere, but rise and set sooner for those in the east than for those in the west. And of this there is no other cause than the bulge of the Earth. So back in the 13th century, they realized, there's a bulge in the Earth. It is a sphere. It isn't flat. So today, of course, you can go high enough in altitude, with balloons or satellites these days, and you can see the curvature of the Earth, especially, from the Apollo landing. Here's the Apollo gear. You can take pictures there over the surface of the Earth, of the moon, and see the sun in the background there. And of course, flat earthers will say astronauts never went to the moon. I'm sure some of you have heard that argument before. And so here's now the International Space Station. That's up 250 miles up in the atmosphere. And certainly from there, they can see the curvature of the Earth. But they don't believe in the ISS there. But clearly, with that, you can see the curvature of the Earth, and a lot of people have taken pictures from that. Here's a snapshot taken from the International Space Station. Here's an astronaut outside. You can see the curvature of the Earth behind him. And another one, the Hubble telescope. And today we have the James Webb Space Station out, and it is out 1 million miles. So why 1 million miles? It gets out of all of the dust on in space, and can see things much more clearly And you may have seen some stories of the Webb telescope. Jason Lyle has written a number of good articles on that. And so we're finding out a whole lot more there with the use of that new space station. Argument number 9 for a spherical Earth is the so-called pendulum. I'm sure you may have seen that in some museums. What is that? It's a pendulum that goes, back and forth. But if the Earth is rotating, it's going to follow a different path eventually. And so you have this pendulum here, let's say it's distance about 200 feet long, it's swinging this way back and forth. But then as the Earth rotates, an hour later, it's going back and forth this way. And those are things that can be measured very clearly. So that proves another proof of a spherical Earth. And this is another one, and that's the previous one too, is really due to the Coriolis effect. You may have heard in from friends that live in Australia, if you drain a toilet or another thing with water in it, it causes swirls. And in the northern hemisphere, it goes one way, and in the southern hemisphere, the water goes a different way, and that's because of the Earth is a sphere. It just does things differently, and especially when you deal with in here, like in the northern hemisphere where we live, you have tornadoes. They go in one way. If you go to the south of the equator, in the southern hemisphere, it goes the other way. Another indication that the Earth is moving. And so these are further, examples of that. I've got them covered in my notes. We won't go into them here. And then we have to know about the celestial poles. If you look at the south celestial pole, this is a sphere, of course. The north celestial pole. Up in the north celestial pole, you have the Polaris star, and that Polaris star is always very, very close to is right on target. But then you have the Southern Cross in the southern hemisphere, which if you live in the north, you can't see the stars in the southern hemisphere. So why is that? If the Earth was flat and all the stars were above you, why shouldn't you be able to see all of them? You can't. So that's another indication, very clear indication that we don't have a flat Earth. And here's one. I've got 2 video clips which I won't show here, but if you go on my website and click on those YouTube videos, you'll see the way that the stars move. Look up in the sky in the northern hemisphere, and you'll see the stars. You can do time-delayed pictures. You can see that the stars are moving counterclockwise. You do the same thing in the southern hemisphere, and they're going clockwise. Why is that? It's because you can't. Those stars move differently. They appear differently in the southern hemisphere. So those are 12 examples that we often use to show the Earth really is a sphere. Now let's challenge the flat Earth model. How do they do? Well, let's look at these 12 things. I just picked 12 because it's an equal number, but there's a lot more in both categories. So the first one, I told you they don't believe in Newton's law of gravity. Well, if you don't believe in gravity, then gravity explains a lot of things in physics. And even Newton's 3 laws of motion are questionable in their view. And then Kepler's 3 laws of planetary motion, which he got, very careful, exact map of the motions of the stars. He came up with those 3 laws of planetary motion. Well, that means nothing to flat Earth people because they just believe the stars are up in that dome in the firmament. And these other principles, they don't pay much attention to. So the laws of physics, gravity, well-defined, the force equal to gravitational constant times mass of 1 and mass of 2, all divided by the distance squared. And that's the laws of gravity that Newton discovered. And but the flat earth people don't believe that. And then Kepler's laws of planetary motion, won't go into those, but it's in my notes as well. So then another thing is, how do you explain ocean tides? We explain it because the ocean has a pull on the earth. And when you're above certain waters, and it depends on the layout of the rocks and how deep the water is. And there's some places in the world you may have heard of the Bay of Fundy, which is probably one of the highest tides, I think 30, 40 feet. And why is that? It's because of the geography where it is. But in most places, you're not going to see that. Here in the Northwest, we do see the tides going up and down in the ocean. So how do you explain that? Flat earthers don't believe in the law of gravity, and so you can't explain it by gravity. They have no explanation for that. If you look at Dubai's 200 proofs of a flat earth, you'll see number 117 and 118, they don't know how to explain it. They cannot. They have no way of explaining that. But in the spherical model, you can. And then, so the ocean tides. Now, another one that, and of course, I'm familiar with because I've flown across the American continent, east and west, many times, back and forth. And if you have to, you'll realize that when you go east from Los Angeles to Boston, it takes 5 hours and 35 minutes, typically nonstop, without this stopping in between. And here's just 2 examples, also about 5 hours and 35 minutes. But if you return, it takes you 6 hours and 20 minutes, the same distance, exactly the same distance. So why is that? It's because of the currents in the atmosphere. The wind circuits are in the atmosphere. So that is holding you back, and it takes long to get back. And if you believe this, the Earth is flat and stationary, there's no way to explain that. Recently, actually this year, June the 3rd, there's an alignment of 6 planets, the ones that we mentioned before, but now these are, you can see them all. These are, you need a telescope to see them all like this. But in some points, they are in exact alignment. Now, if these planets are not moving, the way they are, the heliocentric system, there's no way to explain how they could be aligned like that. Another mystery is in the flat Earth, their description of the sun and the moon doesn't work. The spherical Earth, of course, we know that the Earth has a diameter of 8,000 miles, a circumference of 25,000. Moon has a diameter of 2160. Sun is 400 times the size of the moon, and the sun is 100 times the size of the Earth. Sun is 93 miles out there. Moon is only 239 miles out there. And so to us, I mean, we look in the sky, and yes, the sun, the size of the sun looks to be the same as the size of the moon, but that's because their distance is so far different. How does the flat earthers explain that? Well, they, of course, have this view of a disk, and with the dome above it, and then the sun and moon, they are equal in size, but they're only 32 miles in diameter. How can that be? Just think about the physics. How do we get energy from the sun with 32 mile, across up there? Our sun is a gigantic spherical entity up there. So the sun and moon in the flat Earth, they rotate above the Earth under the dome, and the stars and the 5 visible planets are in the dome as well. And so you wouldn't observe what we actually see in the flat Earth model. You just can't. Spotlight sun, one big, again, they can't explain how it works from physical laws because the spotlight sun supposedly only covers a part of the Earth at a time, and that's we see they can see sunsets, they can see sunrises, but depending where you are, if you're right underneath there, you can see the sun up here. But if you're over here in the edge, the sun could look about 6 times smaller because you're further away. So they can't explain why the sun and the moon are always seem to be the same size, because you can't explain that with this geography with a flat Earth. Sunrise, sunset, again, the sun is always above the Earth. It doesn't go down and under the Earth like that. It's always above the Earth. How do you explain a sunset? How do you explain a sunrise? You can't in the real flat Earth model. Let's see. Well, then you come to solstice. How do you explain the solstice? The seasons that we have. So the sun and moon rotate in the sky. Sunrise, sunset are never below the horizon. Can't explain what causes a lunar eclipse. Can't predict a start, stop, or trajectory of a solar eclipse at all. And here's a picture of the sun in the center and the Earth going around it, every year. And of course, with the 23.5 degree axial leaning, then you get different seasons at different parts of the year. So that explains it. You cannot explain that in the flat Earth model. There's no way you can do that. Here's another look at it. The sun in the middle. You got the Tropic of Cancer, and you got the Arctic Circle and all that. And so here, the June solstice, you got these here, these lines here, the Arctic Circle, up top, and you got the Antarctic Circle down below. The same degrees underneath as above, and you got the Tropic of Cancer. That's how far the sun goes away, and the equator, and Tropic of Capricorn. So that's how we get our seasons, but there's no way to explain that in the flat Earth model. And here's also a puzzle. We had a total solar eclipse last year, April 8th, and 2004. Now we weren't in the path then, but you can see the path of that eclipse. I believe it is about 100 miles wide, so it was totally dark in those 100 miles. And you can see where some of these big cities are. So if you're out here, of course, you won't observe that. But we know exactly where that solar eclipse is going to go. We knew beforehand because with science and measurements and predictions, you know exactly when the solar eclipses are going to come and what they're going to cover. With a flat Earth model, how would you do that? There's no way to describe how that would happen. Especially, it's 100 feet wide. I mean, you can't get, the moon in between the Earth and the sun, because the moon and the Earth, the moon and the sun are both above the Earth. So you can't get the Earth in between. You can't explain it. And then we come to satellites, navigation satellites and other kind of satellites. There are many different kinds of satellites at different heights above the Earth. And I think you might have heard of some of these. But again, flat Earth people don't believe that satellites exist. They don't believe in the International Space Station or the James Webb. They believe that NASA is photoshopping this. So they don't believe in reality that we see out there. So again, the flat Earth cannot predict where this is going to go. So these communication satellites, and here's the different orbit types. They've got a few other slides that show the different kinds of orbits we have, but we don't need to go into all the details. All that is on my notes. But I want to spend a little bit of time on GPS, the Global Positioning System, GPS. I think we all use it going from place A to B. You know, GPS is very useful because it tells you exactly where you are. But and these satellites are 12,500 miles above the Earth. Now that's above the dome, above the firmament in the flat Earth model. So they don't believe that this works necessarily. They believe they use GPS, but they think there's a program in, you know, the cell towers or something, because they can read your position too, and they can make all the adjustments. But I've never seen a program that runs in the cell towers that does something like this. So there's 24 satellites revolving around the Earth at an altitude of 12,500 miles, and they provide geolocation positioning. You have to have 3 or 4 of them in your vision to be able to triangulate to exactly where you are. And so we know this works. And the other thing, since it's that far away, 12,500 miles, you got to make adjustment because the light or the waves, the radio waves need to go up that far and back down. And so there's a lag in time that you have to take care of, because if you didn't correct it, you know, your GPS wouldn't work at all. And then another one, number 10, land surveying. The corrections are needed for curvature and refraction. And if you are doing land surveying on a large lot, if you do it on a number of small lots, you don't need to make correction because it's so small. But if you do a large area, you got to make corrections for refraction and curvature. And this is documented in land survey documents. And flat earthers just don't know how to deal with that. They just says they don't work that way. And then another one, Earth's curvature in a battleship, you have to correct, you know, for that. If you got a ship over here, you know, hundreds of miles away, you can't just do it in a straight line. You got to make a correction for the distance and the curvature of the Earth and other factors as well. And so this is real, and there's no way in a flat Earth that you can explain that. There are tables in the Navy's manuals, for example, which document exactly how much you need to adjust by. So if you go like 17,000 yards, and you know, the degrees and the corrections are tabled here. So the corrections are necessary in you know, battleships. And then finally, another one they can't explain. Remember, we know that the Antarctic is I think it's the 5th largest continent on the Earth. It is a very large land mass, and we have places here which are known by name. And what the flat earthers have done is said, well, no, that doesn't exist. You know, we can only go so far up to the Arctic Circle, and after that, it's, you know, there's a wall that you're going to run into, and you can't go any further. But that's in reality, that's not how it works. So, in fact, I show the picture here where the Antarctic circle here is broken up into areas that are claimed by different countries. So it's like a pie cutting, okay, like shown here. And so certain areas that are dedicated by certain countries, they can run experiments in their areas there. If the Arctic Circle is really, you know, not a land area like that, how would you divide it up? There's no way to do that. So here's a picture of the Antarctica from a space probe, you know, hundreds of miles up. And of course, you can see the curvature and the ice and snow in Antarctica. It's not a wall. So then those 12 things. I just picked those 12. They cannot explain that through any physics laws, how that works at all. So what assumptions do they make? And is there any support for those assumptions? Because their conclusions are based on assumptions. And here are the 12 assumptions they make. And the problem is they can't prove those assumptions. You know, gravity, we talked about, things fall down because of density of the air and the buoyancy. We have see no evidence of that. The Earth is stationary, does not rotate. That's what they believe. And so, you know, it means you can't explain a lot of things that we see. Space does not exist. Nothing can orbit the Earth. Newton's 3 laws of motion are fake. Kepler's 3 laws, planetary motion, are fake. There's no satellites, no space stations. Astronauts have not been to the moon. NASA lied about everything they claim. NASA photos are fake. And so they don't believe in space above the firmament. And so they say photos by NASA are just photoshopped. You know, they're fake. And then finally, the Arctic is an ice wall around the Earth disk, and we know that that's not so. So then I come to, we're sitting at the table here, surprised that some people know about the final experiment. This is an experiment that was initiated by a pastor in Colorado. He wondered why people believed in a flat Earth. So he was looking for an experiment that could be run to prove that the Earth really is spherical and not flat. So that experiment is seen to be a way to settle the shape of the Earth debate. Both the flat Earth side and the globe side agree that whether or not there is a 24-hour sun in the Antarctic will confirm if we live on a flat plane or on a globe. A 24-hour sun cannot work on a flat plane in the south, and the sun cannot set on a globe during the summer, the southern sun. So, as you know, in the Arctic, you know, there are days when the sun is out 24 hours for a number of days, and that's because of the 23.6 degree tilt of the Earth. And so when the sun is at a certain space, like in June, you know, the sun shines for 24 hours. So that if the in a spherical Earth world, then you should expect in the Antarctic, you know, the next 6 months later in the December, that you should be able to see the sun there for a number of days for 24 hours. So that's the experiment. And some flat Earth people agreed to go down to the Antarctic to test that out. And here's the test. So now they chose 3 different places, you know, on the Antarctic ice wall. Well, see, they believe that these places are somewhere on this ice wall. We know from physics that they really are part of the Antarctic as a continent. And so if I want to travel from this camp to McMurdo Station in this world here, I'd have to go tens of thousands of miles. But if it's a continent, the Antarctic is a continent, then it's only, let's say, 1,000 miles to travel, much less. So this is not a workable picture. And this, again, this shows the, you know, where these places are, these camps in these cities, well, not cities, but mostly towns, base camps. So these are placed here on the spherical Earth, and the Antarctic as a circle. But as you can see, the distance here is not that great across. But in a flat Earth world, you know, these places would be, you know, on their edge, and that just doesn't work. So and here's another picture here. There's a, you know, where the people have traveled from New Zealand to certain, you know, the cove here in the Antarctic, and they know what the distance is. But if you have to do it on a flat Earth model, it just, again, you can't explain that. You can't measure that, can't show that. So in conclusion then, here's what I conclude. Some ancient cultures did believe in a flat earth a long time ago, but the early patriarchs did not teach a flat earth, neither did the early church fathers teach a flat earth. The Bible text does not require a flat earth, as the flat earthers who are believers will claim that it's needed to satisfy the Bible. And then observations from the 5th century BC to the 19th century AD showed the Earth to be a rotating sphere. Okay, even the early Greek philosophers and astronomers, they said we live on a rotating sphere. An incomplete experiment by Samuel Rowbotham in 1838 renewed interest in a flat Earth. Before that time, there wasn't a whole lot of interest in thinking the Earth was flat. Everybody believed that it was a sphere. But with his experiment, he said, no, it's flat. And he had quite a following, and that's how that movement grew. And so today, we have a lot more people who believe in a flat Earth because of the internet. Word gets around much quicker. So scientific observations show the Earth to be a sphere. The flat Earth model fails to explain observations. Those 12 examples I gave you, you cannot explain the flat Earth in that view. There's a wide use of social media today, revived interest in the flat Earth. Assumptions made by flat earthers cannot be verified. The spherical Earth is supported by the Bible and by science. We believe it's spherical. So why do some people believe it's flat? I claim this. They were deceived by Samuel Rowbotham. He came up with, I mentioned this, esoteric astronomy. It's not real science. He came up with a view that doesn't match reality. And people came to believe in that because they wanted to believe that the Earth is flat. So these people are deceived by this zetetic astronomy that Rowbotham came up with. And his astronomy, just a few words here, is a deception. For example, he came up with the ideas that the flat disk Earth is centered at the North Pole and that there is such a thing as an Antarctic ice wall. He came up with that idea in 1800 because he's looking for support for the flat Earth model. And where did you ever hear about a spotlight sun before? I never heard of it until I started digging into this. And I don't know if somebody's ever, come across that, but he came up with that idea. And that's part of the deception because there is no spotlight sun. It cannot work. It cannot warm the Earth. It cannot provide light to the Earth that we see today. So the zetetic method of empirical observation is this. They look at perspective and atmospheric effects that explain the apparent sun's rising and setting without going under the sun. So they look for ways to explain it, but they can't explain it with real science. They emphasize direct observation. If they can't see it, then they don't believe it. But they do consider personal experiences, okay, over established scientific theories or assumptions. And they're heavily influenced today by literal interpretation of biblical passages and 19th century tension between science and religion. And they have rejected mainstream astronomy. So that's their deception. And the major tenets of zetetic astronomy is a flat Earth as a stationary plane. Sun, moon, stars move above the Earth. Sun's rising and setting due to perspective. There's no curvature, there's no rotation, there's no movement of the Earth. Knowledge is derived from direct observation and sensory experience, not from theoretical models or trust in scientific authority. The Antarctic ice wall as a boundary is part of that. Celestial bodies are not what they seem to be. You can see celestial bodies, but they're not what you think they are. And they reject the law of gravity and skepticism of scientific institutions. So with that, that's what I'm prepared to give to you tonight. I hope it was enlightening, and I hope I haven't convinced anybody that the earth is flat. So thank you. And remember, my notes, very copious notes, I spent more time doing this than I should have, because there's more important things to talk about. But here's my website, and you put flat-earth, all of my notes, and they will point you to the presentation as well, that you could download these PowerPoint slides from as well. So again, thank you.